Hi guys, on this video, I'll be going over the topics of dimensional analysis. And this is such a powerful and important topics that you need to learn very well here in this class. Because we will be continuing to use your knowledge from this topic right here and apply that throughout this whole semester to be able to solve chemistry problem. So therefore, it's very important that you learn about dimensional analysis and know how to solve problems using dimensional analysis. So first, what is dimensional analysis? Dimensional analysis is a problem-solving method that utilizes conversion factor. And it is extremely helpful in solving chemistry problem and also all the types of problem that we have seen in algebra as well. Okay, and so here is the strategy in dimensional analysis right here. In order to solve problem using dimensional analysis, we need to do the following step. The first step is to identify the three components that we call the starting unit, and we're going to abbreviate starting unit with SU. And the second one is the wanted unit, WU, and then the other one would then be referred to as the required conversion factor, and that is abbreviated with CF. And we also need to know the physical quantity that this unit belongs to. Okay, so let's recap. First, identify these three key components: the starting unit, the wanted unit, and the conversion factor, and know what physical quantity that they correspond to. And the second step is to then set up the conversion pathway, where we would then convert the starting unit into the wanted unit by using the conversion factor. Okay, so now let's go over the first step, how to identify the starting unit, the wanted unit, and the conversion factor. So the starting unit, what is it? It is basically the condition that is set by the problem. Every problem would have certain condition or certain starting point with it in it. And it's important we know what units is it that we are starting out. And we also need to know what physical quantity that this unit belongs to. Finding the starting unit is often the most difficult part in solving problems using dimensional analysis. And whenever we are not able to find the starting unit easily, then one trick to help us see this is to rephrase the question to be able to identify it. So forget the detail in the problem, but ask yourself, okay, essentially, what is this question asking me? And ignoring as much detail as we can. And that will then help us find what is the starting unit. And the wanted units is basically the unit that being asked by the problem. And this is often the easier thing to find, because basically just by looking at the question, we'll be able to figure out what is the wanted unit. And lastly, the conversion factor. What are conversion factor? These are basically tools that allow us to convert a starting unit into the wanted unit, right? And many conversion factors show the relationship between the starting physical quantity and the wanted physical quantity. And it may involve multiple steps to be able to convert from the starting unit into this wanted unit. Okay, so within every problem, you will be given conversion factor that show the relationship between the starting unit and the wanted unit. So it's important that we know how to identify this. And like all other conversion factor, it allows us to convert a quantity of one unit into a quantity of another unit. Okay, and now if the starting unit and the wanted unit belong to the same physical quantity, for example, both of them are length, belong to the length physical quantity, or both of them belong to the volume physical quantity, then to be able to do this conversion right here, we will then use something that we call the stock conversion factor. So these are the conversion factor that we know already among units within the same physical quantity. Versus if the starting unit and the wanted unit have different physical quantity to them, then that when you need to start looking for a unique conversion factor that need to be provided by this problem right here in order to solve this problem. Okay, so if these two things have different physical quantity to them, then within the problem, that is where you'll be able to find that unique conversion factor that will allow us to solve this problem right here. And before we move on to example, I wanted to perhaps give you this analogy right here to help us understand the approach to dimensional analysis. So solving problem using dimensional analysis is basically very similar to navigating from point A to point B. So let's say that your friend call you on the phone and ask you, hey, can you provide me direction? Help me find direction, please. Then the first thing you're going to have to ask your friend is, okay, where are you, right? Where are you? Because if you don't know where your friends are, you're not going to be able to give your friend the right direction to get from another place. So very important that we ask, where are you? And we know where that person started out. And that's important right there. It's the same thing in finding the starting unit in solving problems using dimensional analysis. We need to know what is the starting unit. And sometimes finding where we are, if we get lost, finding where we are, it may not be easy to do. We have to look for clues, look for street sign, and if there's street sign, but if there's no street sign, then now it's going to become very, very difficult for us to know where we are. And this is the reason why that oftentimes it is quite difficult to find the correct starting units. So therefore, please watch out for that. And now, once we know where the person is at already and where the person needs to go, then now you can give them the instruction. Okay, so first step, make a left, make a right, and then so on to be able to get to the final destination. And the final destination, that would be equivalent to the wanted unit. Okay, so therefore, very important that we know where to find all of these three components right here. Let's now do some practice problem to find the starting unit, the wanted unit, and the required conversion factor. So here is the first example. Mary just turned 19 years old. How many seconds has she lived? Okay, so that is the problem right there. What do you think the starting unit would be? So in this case, Mary is 19 years old. Now, how many seconds have she lived? So in this case right here, very clear that the starting unit or the SU here would then be years, right? And the value associated with this years would then be 19. So we're starting from 19 years. So that would be the starting unit and the quantity of the starting unit, 19 years. And now the wanted unit would then be second. The value to this second right here, this is the answer that we'll be looking for. And now we need to now identify the physical quantity that this unit belongs to. Years is a unit of time. And second is also a unit of time. So in this case right here, to be able to convert from the starting unit into the wanted unit, we are converting from time to time, from year to second. So therefore the required conversion factor would then be something that will relate time to time, because we convert from time to time, and in this case right here, from years into second. So this is when we know that we need to use the stock conversion factor, because if we convert it from unit belonging to the same physical quantity, we will be using the stock conversion factor. We know how to convert from year to second, right? We can convert first from years into days, and days into hour, and hour into minute, and minute then into second. But essentially, several steps are needed in order to be able to convert year from years into second. But we'll be using the stock conversion factor to do that, because it converts among units belonging to the same physical quantity. And now, let's now try example B. So why don't you go ahead and take a minute to do this, find the starting unit, the wanted unit, and the required conversion factor before we go over this together. So please pause this video. And now let's go over this. So it says the following: the distance between Sac City and CRC is 15.1 kilometer. If you are driving at the speed of 65 miles per hour, how long in minutes will it take you to drive from Sac City to C or C? So here in this case right here, what would be the starting unit? And what would then be the wanted unit? And what would then be the required conversion factor? So first, in this case right here, we would then see that it's quite easy for us to identify the wanted unit. The wanted unit is hour, right? How long? I'm sorry, in minute. How much time do it takes? That's what we're solving for. How much time in minute? So in this case right here, minute. That is the wanted unit. And now what would then be the starting unit? The starting unit is basically the distance from Sac City to CSC. So given this distance, that is 15.1 kilometer, how much time will it take for us to get from point A to point B? So in this case right here, the starting unit is the distance of 15.1 kilometer. So there you go. Now that we know that the starting unit is kilometer, 15.1 kilometer, and the wanted unit right here in minute, we would then see that kilometer is a unit of length, right? Length and distance refer to the same thing, and minute here would then be the unit of time. It corresponds to the time physical quantity. So in order for us to actually solve this problem, we need to use a conversion factor that relates length to time. So that's what it is. Something that will convert length into time. So that is the required conversion factor. And that's something that we need to start looking for in the problem. In this problem right here, because length is one physical quantity and time is a different physical quantity. So within this problem, they have to provide us with the relationship between distance, between length to time. And that is what this speed would be. 65 miles per hour means that the 65 miles equal to 1 hour. So in this case right here, miles is the distance of length and hour is the unit of time. So essentially this conversion factor right here is then given to us. And this is the piece of information that we have to use to be able to solve this problem. And now, let's now try another example. And again, please take a minute to do this before we go over the answer. So now, what would then be the starting unit? And what would be the wanted unit? And what would be then the required conversion factor? So in this case right here, let's read through this problem. It says a barrel contains 59 gallons of wine. How many bottles would be required to contain this much wine? Each bottle has a volume of 750 milliliter. So you have a barrel of wine with a volume of 59 gallons. And now we need to figure out how many 750 milliliter that we need in order to bottle this one barrel of wine. So that's essentially what this question is asking. So the wanted unit here is the bottle. How many bottles? And now the starting unit in this case right here will then be 59 gallons of wine. Okay. And now to help us figure out what would be the required conversion factor, we need to again look at the physical quantity of gallon and bottle. So here in this case right here, gallon is a unit of volume, belong to the volume, physical quantity. And then bottle is simply the amount of substance. In this case right here, bottle, number of bottle. In order for us to solve this problem right here, the problem has to provide us with a relationship between volume to the number of bottle. That is something that is very much needed, because without it, we will not be able to solve this problem. So what would be the relationship between volume to bottle? So the required conversion factor would be something that relate volume to bottle, or number of bottle. And here in this case, we've been told the following. Each bottle has a volume of 750 milliliter. So 750 milliliter equal to one bottle. So this is the conversion factor that relate volume to the number of bottle. And that is something that we need to use in order to be able to solve this problem. Okay, so first, make sure you know how to identify the starting unit, the wanted unit, and the conversion factor that they require. And now let's move on into more about conversion factor, because it's quite important that we know how to use conversion factor and express them as a fraction. So conversion factor are again tools that allow us to change a quantity of one unit to a quantity of another unit. And any equal relationship can be used as conversion factor. So whenever we've been told two things are equal to each other, then that can essentially is an equal relationship that can be used as a conversion factor. So, and conversion factors show the relationship between two and sometimes more variable or units. And when we have a relationship involving multiple variables, we can select any two of the variable and write conversion factor among them. And the conversion factor can then be expressed as a fraction, where the unit on the denominator is being used to convert into the unit on the numerator. So conversion factor can be expressed as a fraction, and they have meaning to them depending on how we set up the fraction. For an example, let's say we have this equal relationship right here, x of unit A with equal to y of unit B equal to z of unit C, where x, y, and z are values, and A and B and C are three different units here in this case. So we have a equal relationship involving three variables or three different types of units. So essentially what we can do is pick out any two of these three variables right here and then write conversion factor among them, where we can express them as any fraction. For an example, let's say now focus on unit A and unit B. So when unit A, x of unit A equal to y of unit B, mathematically speaking, when two things are equal to each other, when we take one divided by the other, we will be able, it will equal to 1, right? So we basically can write this as the following: x of unit A over y of unit B will then equal to 1. And that's how we can write that as a fraction. Or conversely, we can also write the following: y of unit B over x of unit A would still equal to 1. So basically we can write them whichever one on the numerator, whichever one on the denominator is fine, because mathematically they would equal to each other. However, they have different meaning to them. When we put unit B on the denominator and unit A on the numerator, then this conversion factor right here is then used to convert unit B into unit A, because you always end up with the unit on top. Okay, versus the other way, when we put unit B on top and unit A on the denominator, then now this conversion factor right here is used to convert unit A into unit B. So you end up with the unit on the numerator. So that's what it would be. One is to convert from B to A, the other one is convert from A to B, depending on which one we put on the top and which one we put on the denominator. Another thing that is very important that we have to pay attention is as follows: x should always go with the unit A. So if we put a unit A on top, x has to also be on top as well. Versus if we were to put unit B on the bottom, then x has to go on the bottom as well. So x and the unit A should always come together because they are one term in this equation. And similarly, y should always go with the unit B. Okay, so please do not mix this up, because there's a lot of time we see students move the unit but not the value, and that way we now end up with the incorrect relationship. Now similarly, we can also pick out unit A and unit C and write conversion factor among them as well, right? And we'll have the following: x of unit A over z of unit C. And of course, we can also write another one where C will be on top and A will then be on the denominator. Or we can also do this one as well, the relationship between unit B and unit C, where we can have Y of unit B over Z of unit C. And again, make sure the unit and the value go together. This conversion factor will be used to convert unit C into unit A, versus this one right here will be used to convert unit C into unit B. So that's what conversion factor are. Anytime we have an equal relationship, whether it is two variable or many variable, we can select out any two and write fraction for them. And depending on how we write our fraction, they have different meaning to them. To convert from A into B or B into C, depending on which one we put on the top and which one we put on the bottom of the fraction. Now, more information about conversion factor. Where do we get conversion factor from? Then conversion factor are derived from a number of sources. First one, the stock conversion factor. So this is something we have heard and seen already. So for each of the 7 base physical quantity, base of fundamental physical quantity, there's a many conversion factor within them, and among them as well, between the metric system and the English system, right? So this is something we refer to as the stock conversion factor. Measurement conversion factor between meter to kilometer to mile, between the metric system and the English system. And basically all of this are conversion factor within the same physical quantity. So all of this are for length, and all of this are for mass, and this would then be for volume. But each physical quantity have conversion factor among them, and this is something we call the stock conversion factor. Now let's try an example right here. So let's say here we have 1000 millimeter equal to 1 liter equal to 0.264 gallon. So in this case right here, we can do the following. We can select out this tube, and I'll say 1000 milliliter over 1 liter. Or we can also do 1000 milliliter to gallon, and I'll say 1000 milliliter equal or over 0.264 gallon. And we can also do the following: 1 liter over 0.264 gallon. When 3 things are equal, we can now have 3 unique conversion factor that convert among them. And similarly, we can do the same thing for this one. Now I wanted to perhaps mention this so that way when you see this, you're not getting confused by this. In this case right here, we see 1 liter is equal to 0.264 gallon. Some of you may have seen this other conversion factor right here, where we have 3.785 liter equal to 1 gallon. So gallons and liter are related to each other, and they can either be related by this value right here, 1 here to 0.264 here, or 3.785 here to 1 here. So both of these are exactly the same thing. Now the reason why they look differently because of the following. Here in this case right here, liter is set equal to 1. And now this will be the value gallon versus other one, this other value. Now gallon, the unit gallon is now set equal to 1. And this is how many liter equal to. Okay, but mathematically they are the same thing. Because if we were to now take 1 divided by, if we were to divide both this side by 0.267 to convert gallon into 1, when 1 divided by 0.267, it would then equal to 3.785. So mathematically they are the same thing. We can use either one of them and they would be the same thing. So that's the first place for us to get the conversion factor from the stock conversion factor. And now the second one, the second source of a conversion factor is something that we call the per expression. And per expression are basically any types of expression with the word per in it. And so basically relationship with the word per in them. For an example, when we say 60 minutes per hour, then that is called a per expression right there. Or perhaps maybe another one, 7 days per week, then that is another per expression right there. And anytime we see the word per, we can now see that we can write that as a conversion factor or as fraction. So for an example, 60 minutes per hour is a per expression. And from here, we can write the following: 60 minutes over 1 hour, or the opposite, 1 hour over 60 minutes. Make sure the 60 go with the minute and the 1 go with the hour. Do not only swap the units, the unit, but not the value. For an example, if you were to write the following, say 1 minute over 60 hour, that would be wrong, right? Because this is an example when someone swap the unit but do not swap the value. So this is wrong. 1 minute is not equal to 60 hours. And the other example, 7 days per week. So in this case right here, we can write 7 days over 1 week, or 1 week over 7 days. 65 miles per hour, that is also another per expression as well. So can you think of another per expression? Please do, and think of one and then write them as a fraction. So you learn how to convert a per expression into a fraction. And now we're moving on. The third place for you to get conversion factor. In this case right here, I call this the unique conversion factor from information given by the problem. So in nearly every word problem that you see here in chemistry, you will be given or provided with a specific or unique information or relationship that will be crucial to solving the problem. It is very important that you recognize this information right here and know how to express them as a conversion factor. For an example, here is the first one. The average mass of a blueberry is 0.75 gram, and the average mass of an automobile is 2.0 times 10 to the third kilogram. So in this problem right here, you are actually provided with a lot of information that we can use as conversion factor. For an example, we've been told the mass of a blueberry is 0.75 gram. This means the following: one blueberry equal to 0.75 gram on average, right? It equal. So therefore now we can write the following: one blueberry, so BB stands for blueberry, over 0.75 gram, or 0.75 gram over one blueberry. So the importance of this conversion factor is as follows. It converts mass, because gram is a unit of mass. And blueberry is the amount or the number of blueberry. So this conversion factor right here will allow us to convert from mass into the number of blueberry. And same thing, this one right here will convert the number of blueberry into the unit of mass. So that one. And now we also been told the mass of the automobile, right? So one car equal to 2.0 times 10 to the third kilogram. And from here, we can also again write a set of two fractions that are reciprocal. So one car over 2.0 times 10 to the third kilogram, or 2.0 times 10 to the third kilogram over one car. So the importance of this conversion factor is that it will allow us to convert kilogram into car. Kilogram is a unit of mass. And car here is simply just the number of car. So this conversion factor right here will allow us to convert from mass into car. And now here is the cool thing about this problem right here. We've been told of this several variables that involve the blueberry, the car, and the mass, right? Because blueberry is related to mass, and car is also related to mass as well. So essentially, the blueberry can be related to car as well. So please take notice of that, okay? And now here is another example right here. So please learn to recognize the conversion factor that are given in this problem right here. So at room temperature, a bottle of water with a volume of 20 milliliter is found to weigh 19.998 grams. So in this case right here, we've been told we have a bottle of water and have this volume and have this mass right here. So we can write the following: one bottle equal to 20 milliliter, and it then equal to 19.998 grams. Okay, and we also need to put in water as well, so that way, because this relationship right here is only true if the substance is water. So one bottle of water equal to 20 milliliter of water and equal to 19.98 grams of water. So from here, we can again select out any two of these three conversion factor and write conversion factor among them. For example, we can select bottle and volume, and we'll be able to do the following. So this is a unit volume, and this is unit mass, and this is the number of bottle. So we can say one bottle over 20.0 milliliter, and make sure we also put in water as well. And similarly, we can also use this relationship right here: 20.0 milliliter of water is equal or over 19.998 grams of water. Okay, and the other one, the relationship between bottle to mass: one bottle of water has the mass of 19.998 grams or over 19.998 grams of water. And clearly, each of this fraction right here will have different meaning to it, right? This first one right here will allow us to convert from volume, because milliliter is a unit of volume, into the number of bottle. Versus this second one right here will allow us to convert from mass, because grams is a unit of mass, into milliliter, which is the volume of water. So this is the conversion factor that allows us to convert from mass into volume. And this conversion factor right here will allow us to convert from mass into the number of bottle. So each of this conversion factor have different meanings to it. Okay. And now, the fourth place of where we can get conversion factor from. So throughout this whole class right here, we will learn of many other unique conversion factor that you will see here, only here in chemistry. And you need to pay attention and be able to use them as conversion factor. And this is very important right here, because throughout this whole class, we'll be using dimensional analysis to solve problems. And that's when you have to learn how to recognize information as conversion factor. For an example, one of the unique conversion factors that you see here in chemistry is as follows: 1 mole equal to 6.02 times 10 to the 23rd units. This is known as the Avogadro constant, and that's something we'll learn later. But because these two variables are equal to each other, we can now write the following: 1 mole over 6.02 times 10 to the 23rd units. And another types of another way Another source of where we can get conversion factor from would be from the chemical formula of a substance. So given the chemical formula of a substance, we can also write a lot of conversion factor. For an example, let's say the chemical form of water is H2O. From here, we can say the following. For every 2 hydrogen atom, there's 1 oxygen atom, right? And so 2 hydrogen atom equal to 1 oxygen atom in water. So therefore, we can now write the following. 2 H atoms over 1 O atom. And this relationship would only be true if the substance is water. And we can also see the following. For every 2 hydrogen atoms, it is present in 1 water molecule. So 1 water molecule have 2 hydrogen atoms. So therefore, we can also write this conversion factor as well. Now clearly, we'll spend more time learning how to recognize chemical formula and be able to use them as conversion factor later. And this is another example, density of a substance, that is also a conversion factor as well. So the density of water is rounded to 1.00 gram per milliliter. So what this means is 1 milliliter of water is then equal to 1.00 gram, right? And now we can write the following. So let's put in water to make sure that this is correct, because this information is only true for water. So we can now write the following. 1.00 gram of water over 1 milliliter of water. So density is basically a conversion factor as well. So if you're being told of the density of a substance, then essentially we can use that as conversion factor and allow us to convert volume of a substance into mass of the substance. And we'll go over more information about density in a little bit. And now finally, putting all of this together, forming the solution map and the conversion pathway. So once all of the components, the starting unit, the wanted unit, and the required conversion factor are all identified, we can now arrange all of this information together into something that we call the conversion pathway. And in the conversion pathway, it will then allow the unit to be cancelled out. And here is how we would set up the conversion pathway right here. First, formulate the solution map first. Okay, so set up the conversion pathway. First, form the solution map. The solution map is basically a similar to having a strategy of showing how the steps and the order of the step in order to be able to convert from one unit into another unit. Now, a lot of time when we convert from the starting unit into the wanted unit, it may require one step or multiple steps, and the order of the step matter in case it requires multiple steps. For an example, let's say that we starting from the unit A, and our wanted unit is the unit E. So to get from A to E, it will require several units, right? So in this case right here, we have to use, in the step 1, we have to use the first conversion factor to convert between unit A into unit B. And then we'll then be able to convert unit B into unit C by using the conversion factor that relate unit B to unit C together. And once we have obtained unit C already, we can now convert that into unit D by using the conversion factor that show the relationship between unit C to unit D. And then finally, to be able to convert from unit D into the wanted unit E, you now need another conversion factor in a separate step that will relate unit D to unit E. And that's how we'll be able to do it. So that's what this solution map is. It shows us the step by step how to ultimately convert from unit A into unit E. And finally, the conversion pathway. In the conversion pathway, then you will start out from the starting unit, and then we will be able to then achieve the conversion between each of this step right here by using the appropriate conversion factor. And we would always start the conversion pathway with the starting unit and the quantity of the starting unit. So again, always start with the starting unit. Just like when we navigate around, we always start at point A, right? point A and now get into point whatever that we need to, but we always have to start with the starting unit and the quantity of the starting unit. So here is the example right here. To achieve the conversion that we have seen above, we will start out with this conversion factor, followed by drawing this line right here, this big horizontal line. And this horizontal line right here would then represent a big fraction, and it means division. Thing on top and thing on the bottom will be divided by each other, just like what we have seen in the fraction. So everything on top of the line will be units that are on the numerator, and everything on the bottom of the line will then be the denominator. Okay, and the vertical line here represent multiplication among all of these units. So this means A multiplied by B multiplied by C, and so on. So to be able to convert from unit A into unit B that we have seen here, we need to have a relationship between A to B. And now we'll be putting unit B on the denominator, because we need to convert that into unit B, right? So we'll put A on the denominator and B on top. So that will be the first conversion factor that we have to have in order to convert from unit A into unit B. And this is how we will do it. Now when we do this, then now the unit A will then cancel with the unit A, and we'll end up with unit B on top. And to now be able to convert unit B into unit C, we need to have the conversion factor between unit B and unit C. And we have to put unit B on the denominator, and now unit C on the numerator. And now unit B will then cancel with this unit B right here. And on the next step, we now need to convert C into D, and again we need the relationship between C and D, and we have to put C on the denominator so it gets cancelled out, and we end up with D on top. And finally, we need the last conversion factor that relate unit D to unit E, and we have to put unit D on the denominator, and now that will cross out with it. And because all of this represent a fraction right here, so anytime we have unit on the top and unit on the bottom, they will cancel each other out. Okay, so similar unit. On top and bottom, or numerator and denominator, will cancel out. Okay, and we should end up with the wanted unit on the top. And now finally, to solve this mathematically, when we have this value right here, then we would then multiply all of them. So value A, so everything on top would be multiplied by each other, and everything on the bottom, all the value on the bottom, would be divided by each other. So in this case right here, mathematically, when we put this in the calculator, it would equal to the following: A times B times C times D times E, because all of these are the unit on top. And now the value, the unit value on the denominator, we have X, and again make sure we put a parenthesis around it as well, multiplied by Y, and multiplied by Z, and multiplied by W. Okay, so don't forget the parentheses, so that way it can mathematically equal out. And now when we finally round this, we will then obtain the answer, right? So this will be the answer, and we will then have the wanted unit E. This value right here need to be rounded. How should we round this final answer of this value? The answer, because the math that we're doing right now, would be multiplication and division. So therefore, we round based on sigfig. Okay, so round to the least amount of significant figure. Ask yourself or identify which of this value right here have the fewest amount of significant figure, and now the final answer would be rounded to that same number of significant figures. And finally, let's now apply all of this and solve problem. So summary of the step in dimensional analysis and now solve problem. So let's summarize what we have discussed so far. So here are the steps right here in solving problem using dimensional analysis. First, identify our starting unit, the wanted unit, and the conversion factor. And the second step, strategize by formulating the solution map and set up the conversion pathway. And then third step, solve mathematically and round the final answer using the rule of significant figures. So let's now apply this to solve some of the examples that we have seen already. So on the first one, Mary just turned 19 years old. How many seconds has she left? So here in this case right here, we have found the starting unit and the wanted unit in this problem already. Let's now put all of that into the conversion pathway. So that to briefly remind here in this case right here, the starting unit is 19 years. And years is a unit of time. And the wanted unit is second. And second is also a unit of time. So therefore the required conversion factor that we need to have is something that relates time to time. And because it requires converting one unit of time into another unit of time, therefore we will be using the stock conversion factor. Okay. And now here will be the solution map. SOLN stands for solution. So the solution map again always start out with the starting unit, and we starting out with years. And clearly we can't convert from year into second immediately in one step, right? Because that is not the type of conversion factor that will be provided or one that anyone would remember. But we know how to convert from years into days. And day is another unit of time, right? And then from day into hour, and hour into minute, and then minute then into second. So there you go. So that would be the solution map. First, to convert from years into day, and then day into hour, and hour into minute, and minute into second. And finally, the conversion pathway. Let's now set this up. So always start with the starting unit and the quantity of the starting unit. So which is 19 years. And now draw one big line across that represent a big fraction. And first, we now have to convert from year into days, right? And we know the relationship is 1 year equal to 365.242 days. If we were to actually count leap year as well, so on average, that's how many days it would equal in 1 year. And so we will put in year on the denominator because we want year to get cancelled out. And on top, it will be 365.242 days. So that would then be the first step. And now we know year would be cancelled out. And now we have to convert from day into hour. And the relationship between day to hour would be there are 24 hours in 1 day. And again, I'm going to be putting day on the denominator, right? Because we want day to get crossed out. And on top, we put in 24 hours. And next, we need to convert from hour into minute. And we know that for every 1 hour, there are 60 minutes. And now, hour will get cancelled out. And lastly, there for every 1 minute, there's 60 seconds. And so minute would get cancelled as well. And finally, we end up with the unit second right here. And that's the final answer. So we would then, last step, we need to plug all of this into our calculator. So we need to take 19 multiplied by 365.242, multiplied by 24, multiplied by 60, multiplied by 60, and divide by 1 on the denominator. And the calculator answer in this case right here equal to 599,581 and 267 seconds. So that's how many seconds it equal to. And now lastly, the last step, we have to make sure we round this based on the rules of sig fig. So here, in this case right here, how should we round the final answer? 19 years. In this case right here, based on the context of this 19 year, it say Mary just turned 19 years old. So this is exactly 19 years old, right? Now, so let's repeat that. She is exactly 19 years old. And therefore, this 19 right here is an exact value. So therefore, exact value have infinite amount of significant figures, making it always exact. Good. Here in this case right here, 1 year equal to this much day right here. This is basically calculation or measurement value, right? On average, this is how many days are there in a year. So this, based on the context of this value, this is a measurement value. Now the 1 year here would be exact because whenever we set conversion factor between two things, one value have to set equal to exact, and then we measure the other value. So in this case right here, 1 year is exact, so therefore has infinite amount of significant figure. And now we measure the day. In this case, with this value, you have 6 significant figure. Okay, and next one, 24 hours in 1 day. This conversion factor comes from definition, right? So therefore have infinite amount of significant figure as well, since it is an exact value. And 60 minutes in 1 hour is also an exact value. An exact value have infinite amount of significant figure. And lastly, same thing with 60 seconds in 1 minute, have infinite amount of significant figure. So here in this case right here, the value with the fewest amount of significant figure would then be 6. And therefore now we need to round our answer to 6 significant figures. So count on 6, 1, 2, 3, 4, 5, 6. And that we're going to cut off. So this is equal to 599, 581, and 000 second. So that will be our final answer. And now your turn. Please go ahead and try this problem before we go over the answer together. Okay, so let's go over the answer together, assuming you have a few minutes to work on this already. So in this case, our problem, so again, let's read the problem to make sure we clear what it is. So it said the distance between Sac City and CRC is 15.1 kilometers. If you are driving at the speed of 65 miles per hour, how many minutes will it take you to get from Sac City to CRC? So here in this case right here, the starting unit is basically the distance, right? The 15.1 kilometer. And kilometer is a unit of length. And now the wanted unit would then be minute. Minutes is a unit of time. So here in this case right here, we need to be able to convert from length into time. So that is the conversion factor that we need to find within this problem, something that relates length to time. So because once we have identified the starting unit and the wanted unit already, it helps guide us what kind of information from the problems that we need to find, right? And sometimes in a problem, we can give you a lot of information, but not all of that information would be essential, right? For an example, I can say the following: the temperature as you drive a 90-degree Fahrenheit outside, or it's a very beautiful day and all of that, and there are 5 or 6 stop signs between traffic lights between Sac City to CRC. So all of that information right there, we can be providing with you all of that information. But you need to learn to ignore those information because those information are not crucial. Okay, so only pay attention to the crucial piece of information. And that is why it's very helpful to find the starting unit and the wanted unit. So therefore, we know what is crucial. The crucial piece of information that we need is something that relates length to time. And that when you start looking for here in the problem. So in this case right here, you are given this speed. This speed right here is a conversion factor between length to time. So you have 65 miles per hour or per 1 hour. So miles is the unit of length, and hour is a unit of time. So essentially, this is the conversion factor that we need. And now here is what we need to do next. Once we have found already, okay, so this is the crucial piece of information. We have to utilize this conversion factor to be able to solve this problem right here. But are we readily available? Are we ready to use this conversion factor? And the answer is no. And the reason why is because this conversion factor right here, the unit of length in mile, we know that we have to use this, but right now the unit of length is 10 miles versus we start with kilometer. So that tells us that the first thing that we need to do will be to convert between from kilometer into mile first. So a half guide is what we need to do. So the first step is to convert from kilometer into mile, and therefore the solution map. So we need to convert from kilometer into mile first. And once we have mile ready, we can now use this conversion factor, and this will then get us into hour. So this is where this information conversion factor will come in, allow us to convert from miles into hour. And now once we have hour ready, we need to convert this into minute, because that is the wanted unit right there. So the time have to be in minute. And now we can convert hour into minute. So there you go. That will be the solution map. So it's very important that we identify the conversion factor, and as a result, they have the right unit of this physical quantity right here comparing to our started and the wanted unit. And if the units are not the same thing, then that tells us what we need to convert. And now finally, let's now set up the conversion pathway to solve this. We would start with 15.1 kilometer. And the first thing that we need to do is convert kilometer into mile. And the conversion factor between kilometer into mile is 1 kilometer equal to 0.6214 miles. And in this case right here, we have to put kilometer on the denominator, so that way it can cancel out with kilometer on top. And after we have this mile ready, we can now do the following: 65 miles on the denominator and 1 hour on top. And again, why do we have to put mile on the denominator? The answer, so it can cross out with the mile on top. And now we have hour. And now the next one is convert from hour into minute, and we know that there is one for every 1 hour. There are 60 minutes, and we have to put hour on the denominator, so now it can get crossed out. So we'll end up with the unit minute, and that is the wanted unit. So in the end, when we set all of this up correctly, the remaining unit should then be the wanted unit, and that's when we know that we have set this up correctly. So first, plug all of this into your calculator, and again, take 15.1 multiplied by 0.6214 multiplied by 1 multiplied by 60, and of course we can omit the 1, right? And then divided by 65, and the calculated answer would then be 8.6614 minute. So this is the calculator unrounded answer. Now we have to round the final answer. So how should we round this? And again, in this case right here, we have to look at each of the value and determine how many sig fig that it has. The 15.1 here, the distance between Saxony and CRC, this is a measurement value, right? And based on how it's given, you have 3 significant figures to it. This value right here, of course, this value right here, 4 significant figure. This one on the bottom, again, anytime we have 1 here, this have infinite amount of significant figure. And this one right here, infinite amount of significant on top, and on the bottom 2. Because the speed is something that been measured and is a measurement value. So this is why that based on how it has been written, it have 2 significant figure. And lastly, this one have infinite amount of significant figure. So in this case right here, the value with the fewest amount of significant figure is 2. The speed. So therefore, we now need to round this to 2 significant figure, which then equal to 8.7 minutes. Okay. And now let's try this last problem right here. And again, please go ahead and take a few minutes to do this on your own before we go over the answer together. And I wanted to perhaps maybe clearly state this. that when it comes down to solving this kind of problem right here, we expect you guys to be able to solve this really quickly. So if it takes you 30 minutes to solve each of this problem right here, that is way too much time. So this kind of problem right here on quizzes and exam, you will have about 2 minutes to do it. So see if you can do this in 2 minutes. Okay, and in 2 minutes, let's now go over the answer together. So in this case, the starting unit is 59 gallon, and the wanted unit is now in this case right here, bottle, and the required conversion factor, we need something that would relate gallon. Well, gallon in this case right here is a unit of volume, right? And bottle here is the number of bottle. So the required conversion factor we need will be something that relate volume to bottle. And in this case right here, each bottle has a volume of 750 milliliter, and that is the conversion factor that we need. 750 milliliter equal to 1 bottle. And we know that we now have to use this piece of information right here in order to solve this problem. And in order to use it, we have to convert gallon into milliliter first, right? Because our starting unit is gallon. So in order to use this conversion factor, we have to convert the volume from gallon into milliliter first. So that tells us that the solution now would then be first convert from gallon. Let's go ahead and remove the value, gallon, into, well, in this case right here, in order to convert this into milliliter, we have to go into liter first, and from liter into milliliter. And once we have milliliter ready, we can now use this conversion factor to convert this into bottle. So that would be the solution now. And finally, setting this up to solve this, starting with 59 gallon. We have to convert from gallon into liter, and 1 gallon equal to 3.785 liter. And again, gallon have to be on the bottom, so GAL is the abbreviation for gallon. And now we have for every 1 liter equal to 1,000 milliliter. So the liter can get cancelled out as well. And now 750 milliliter equal to 1 bottle. So there you go. And now milliliter would get cancelled out, and we end up with bottle. And lastly, let's now round this. So in this case right here, we have 59, and because this is a volume measurement, have 2 significant figure on it, and this one have 4 significant figure. This one have infinite amount of significant figures since it's come from definition, and this one, the volume of a bottle, is a measurement value and have 2 significant figure on it. So we need to be rounding this to 2 significant figures. So in this case, the unrounded answer is 297.75 bottles. And now we need to round this to 2 significant figures. So this would then equal to, and in this case we have to write this as a scientific notation, right? Because it's not possible for us to express this value to 2 significant figure in the decimal form. So equal to 3.0 times 10 to the second bottles. Okay. Please try the other problem over here. So this is actually a very fun problem, and some of them was questioned from past exams. So see if you know how to do this.